Here is a quick demo in MATLAB showing you a few different ways of computing edges. Note that you can do the same in Octave, just remember to load the image package. Alright, let's read an image and display it. Here we use Figure to open a new window, IamShow to show the image in the window, and Title to set a title. All in one line. We will use this idiom frequently. Let's now convert the image to monochrome or grayscale. We'll use the RGB to gray function for this purpose. And here's what it looks like. Now let's create a smoothed version of the image. First, create a Gaussian filter using the fSpecial function. Here's what the filter looks like. Well, plotting it as a surface might help. Okay, now apply this filter to the image. Compare this with the original. Alright, for the first method, we will shift the image left by 1 pixel, right by 1 pixel, and compute their difference. Let's make a copy of the smoothed version to create the left image. To shift the image to the left, we copy all the pixels from the second column onwards till the end to positions first column to n-1. Note that the last and second last columns here would be identical. Similarly for right. Now we compute the difference, remembering to convert to double type. Note that the difference may contain negative numbers, so to display it correctly, we pass in an empty vector as the second argument to IamShow. Notice how object boundaries are highlighted as brighter or darker areas, indicating greater positive or negative differences. Other areas are almost gray, indicating close to zero difference. Our second method is to use the canny edge detector. We use the edge function passing in canny as the method argument. Remember that the canny algorithm performs non-maximal suppression? That, along with some other tricks, result in a much more meaningful edge image. Let's also run the canny edge detector on the smoothed version of the image. Notice how a lot of the detailed features are now gone. Here is the original set of edges for comparison. Our last method uses Laplacian of Gaussian. You simply need to pass in log as the method argument. Again, the edges found by canny are shown for comparison. You can use docEdge to find out more options that might be available. As you can see, there are other edge operators that you can apply, as well as pass in custom parameters. By this time, you should have MATLAB or Octave installed on your local machine. You will need it to solve the problem sets. Please refer back to the introduction lesson for instructions.